about these polyatomic ions that we have. And these are poly, meaning what? More than one, many, right? Many, atomic, meaning many atoms, and they're ions. And so the basic idea of these polyatomic ions is it's a group of atoms that are bound together, but they carry a charge, okay? So it's different from a compound in that a compound is neutral. These are all ions. What does it mean to be an ion? An ion is anything that has either gained a positive, negative charge, and it's either gained or lost what? Electrons. Awesome. So what happens is this group of atoms all together have gained a certain number of electrons. There's only one on this entire chart that loses. Okay? So let's take a look at these for just a minute here. These all have a -1 charge. That means that as a group, they carry a -1 charge and they all together gain 1 electron. These gain 2 with a -2 charge. These gain 3 with a -3 charge. And this is a +1 charge. Okay? So these, if we thought back to the club, okay, we talked about Club Chem, and we said that sodium's hanging out at the club, having a good time. Sodium is looking to give away 1 electron. Remember, sodium gives away 1 electron. It had 11. If it's neutral, if it gives away 1 electron, it now has 10, like neon, and it makes it more stable. Awesome. With the full energy level, it makes it more stable. So sodium wants to give away 1 electron. What happens with these cliques now is they come to the club and they come as a group. You know these people. They come to the club together, all together. They get out of the car together. They all walk in together, okay? They need to get a drink. They're all going to get lemonade. They all go to get the lemonade together. They all drink it together. They smile at each other together. Then they go to the bathroom. Guess what happens? They go to the bathroom together. Everybody walks in the bathroom together. They're in a clique, okay? They all come together and they leave together as one group. So what we're going to do is, we're going to put them, I'm going to say put it in a bag, okay? What I mean by that is you're going to put parentheses around the polyatomic ion. You're going to treat it as one unit. You may as well call it X, okay, inside of there. And then it carries a charge. So don't get too confused. We're going to try to keep it simple, even though it's a full ion. And I'm just going to ask people to name some of these as we go along. So let's just try it and see what happens here. Let's go back to the notes. And so this just explains a little bit about how we're going to name them. We're going to name them, they're ionic, so polyatomic ions. So we're going to name them the same way that we would the binary ionics. So let's just give this a start. First thing is, let's rewrite the Roman numerals. The Roman numerals are 1, 2, 3. How do you write 4? IV. IV. Good. And then 5 is just a V. What's 6 then? VI. VI. If the I comes after, the way I think of it is you add it. If the I comes before, you're subtracting it from the 5. So then 7 would be VII, and what's 8? VIII, and the highest charge that you're going to get is an 8. Remember that the Roman numeral is written in when you have a variable charge on the metal. So if you have more than one charge on the metal and it's variable, there isn't just one number written, you need a Roman numeral, okay? So the Roman numeral only goes for the metal, not for the non-metal. So let's try this. This says lithium carbonate. So, do you see a prefix? No. You need to write your charges, and then we say criss, cross, absolute, reduce. Awesome, that's what we're going to do. So we're going to write Li, we're going to find the charge of lithium. So take a look at lithium on your periodic table, and what's the charge of lithium? 1. Plus 1. So we're going to write plus 1 up there. And now, I want you to go to your polyatomic ion chart and find carbonates. So it's somewhere in the middle, and as soon as you see it, tell me what you see for the formula for carbonates. CO3. CO3, -2. Awesome. We're going to put it in a bag to start, okay? So that means I'm going to put it in parentheses. So I'm going to write CO3, end your parentheses, and then write the charge on the outside, okay? Basically, we could take this on the inside here to be X. It doesn't really matter, including the 3. We can take it to be anything, okay? So whatever's inside of here, we're kind of ignoring. Now we're going to do our crisscross. And when we crisscross, what do we get? Li2 CO3, but it could just be CO3, okay? It's like treated as one thing. And now what happens? The 1 comes down here, okay? You don't need charges in your final answer. So your final answer, and if there's only one of them, you don't need the bag, and that only matters on WebAssign. So if you're doing a WebAssign problem and you put the parentheses in when it doesn't need it, then it'll mark it wrong. But like for me, if you keep the bag in there, it doesn't hurt. Okay. But the final answer would be Li2CO3. Okay. If you put the 1 in without the parentheses, it looks like 31, and that's wrong. Okay. So let's try the next one. Tin is, everybody find tin on the periodic table, and what's the form, the symbol for it? SF. What is this IV?
The 4.
4. Where does that go?
On top.
On top. That is the charge. You can either just write a 4 or you can write a +4. Okay? So that's the charge of the tin. Now, look at your you know what I wanted to tell you too? When you look at your polyatomic ion list, what do you notice about the names, the ending of the names of all of these? They're either 8 or
Ide.
Okay. There are 2 of them that end in "ide." Cyanide and hydroxide. I don't know why those 2 end in "ide. I'm not exactly sure. But these all have oxygens in them. Almost all of them have oxygens in them. The only difference between the 8 and the "ide," because people will say, wait, does the 8 always have 4 oxygens? No. Because if you look at nitrate, how many oxygens does nitrate have? 3. Sulfate has 4, and phosphate has 4, and chromate has 4, but carbonate has 3. Okay? So typically, 8 either has 3 or 4. Usually 8 has 3 or 4. The only thing is that we do know for sure is the ite version always has 1 less. After I ate, I gained an oxygen, is an easy way to remember that, okay? So if you look, there's nitrite and nitrate. Nitrite is NO2. After you ate an oxygen, it gains an oxygen, okay? So now it's got 3 oxygens. Phosphite and phosphate. Phosphite has 3. 8, after I ate, I gained an oxygen, then that one has 4, okay? So it can be 2 to 3 or 3 to 4. Same thing here on chlorite and chlorate, 2 to 3, okay? So the 8 version always has 1 more oxygen than the ite version. So if you see that it ends in 8 or ite, it's not on the periodic table. Now you're looking at the polyatomic ion sheet. Right, so let's go back. And this one says dichromate. What do you see on your sheet? What does dichromate say?
Cr2O7.
Good. Cr2O7. Put it in a bag. And then it has a -2 on the outside of the bag. Okay, now what do? Crisscross, absolute, reduce. You can reduce both before or after. Let's reduce after on this one, okay? So when I crisscross, what do I get? 2 and 4. Don't worry about what's inside the bag, okay? You're not reducing anything in there. Even if that's at a 2 and a 4, you would not reduce those. You're only reducing, so this you're treating as that's your click. That stays the same, okay? So the 2 and the 4, what can I divide both of them by? 2. That one cancels out, you get a 1, and that one gives you a 2. So when you rewrite it, you're going to get SN1, so you don't have to write that, parentheses, Cr2O7, 2. You do need parentheses on this one. I'm going to erase this in a second, because if you don't put parentheses in, it looks like you have how many oxygens? 72. That's wrong. Okay? You have to put the parentheses in, put it in a bag. If there's only 1 of them, then you don't use the parentheses. But if there's more than 1, then you do have to have the parentheses. Okay, let's do the next one. Nickel 2 nitrate. So nickel's symbol is what? Ni. It's not N because that would be nitrogen. What is this 2? The charge. Perfect. That's the 2 on top. Okay, so now I want you to find, it's not nitride, it's nitrate. If it's an 8 or an ite, you're looking on your chart. Okay? So everybody find nitrate, and on the count of 3, tell me what you found. 1, 2, 3.
NO3.
Awesome, right there, NO3, -1. So I'm going to come back to this, and then I'm going to put in a bag to start. NO3, and then end your bag, and then put your -1 on the outside of it. Crisscross, and what do you get? A 1 and a 2. Remember, absolute value is what you crisscross. So when you rewrite this, you do need the bag. You don't need it if there's a 1 on the outside of it, okay? But if there's anything higher than a 1, You do. So Ni parentheses NO3 2. Okay, last one on this side. Iron Vi is what? 6. Good. What's iron symbol? Fe. So where does the 6 go? On the top. The charge goes on the top, not on the bottom. The bottom number tells you how many. The top number tells you the charge. Okay? And phosphate. On the count of 3, I'll give you a hint. It's on the right. I want you to tell me what phosphate's formula is. 1, 2, 3.
PO4.
PO4 negative 3. Awesome. So we're going to write parentheses PO4 negative 3. Let's reduce first and then crisscross, because a lot of you are going to think that's easier. I think it's easier. So what can I divide both of these by? Same number.
3.
A 3. Good. If I divide this by a 3, I get a 2. And if I divide this by a 3, I just get a negative 1 or a 1. So when I crisscross now, I get a 1 and a 2. So when you write this one, same thing. It's going to be Fe parentheses PO4 2. Okay, let's try to go the other way now. The other way could be easier, but it could be harder. Okay? Half of it is the easiest way to name, and the other half is the hardest way to name. So let me show you what I'm talking about. If your metal has a fixed charge, you name it. For example, sodium chloride is NaCl. Na has a fixed charge, it's sodium chloride. MgCl2 is not magnesium dichloride, it's just magnesium chloride, and you're done. Scandium has a fixed charge. Let's say you had scandium with nitrogen, it would be SCN. It would be scandium nitride, okay? If you had something like strontium SR3P2, it's just strontium phosphide. If it has a fixed charge on the metal, you just name it and you're done. So let's try these. What is Ca, everybody? Calcium. Does it have a fixed or a variable charge? Fixed. Again, if you're confused, if there's only one number, that's called fixed. No Roman numeral, we're done. All you have to do is name the ending. So I want you to find CO3. Now we know it's ternary because there's more than 2 elements. So I've got 1 capital, 2 capitals, 3 capitals. The first one's going to be a metal. The end of it is going to be your polyatomic ion. So once you start learning your polyatomic ions, you'll recognize it. So anybody know what CO3 is? Just say it. 1, 2, 3. Carbonates. So all you're going to do is name this calcium carbonate, and you're done. Try the next one. This one has 1, 2, 3, 4 elements. This one actually has 2 polyatomic ions in it. Anybody recognize one? Good. NH4 is in the bottom right corner, ammonium. What about ClO2? Find that. Chloride. What's that? Chloride. Chloride. Awesome. So let's leave a little space. We're going to write ammonium first. Leave a little space in case we need a Roman numeral. And then it's chloride. When do you need a Roman numeral? When the metal has a variable charge. Awesome. Is there even a metal here? No. Ammonium only has 1 charge. If you look at your polyatomic ion sheet, ammonium is fixed at a +1. So you're done. That's it. That's all you had to do for that one. Let's try the next one. Okay, find V on the periodic table, please. What's V? Vanadium. And find SO3 on your chart, please. On the count of 3. It's in the middle section. 1, 2, 3. Sulfite. Leave a little space. Do we need a Roman numeral for vanadium? Yes. So if we take a look at the periodic table, vanadium can either be a 5, 4, 3, or a 2. So we need to figure out which one it is. So what I'm going to do is I'm going to do a plus chart. And I'm going to write vanadium's 5, 4, 3, and 2. It's only one of them. Okay? Sulfite, take a look at sulfite on your chart. What's the charge of sulfite? -2. Okay? Many of you will not need to do a plus chart. You'll be able to see it right away. But here's how it works. You're going to take the factor, you're going to multiply these two together, and I get -2 times 2 is a -4. You do outside the parentheses. That means that this side, if that's gaining 4, then this one must be +4 and losing 4. Good. Which one of these, now if there's no number after the vanadium, it's a 1. So which one of these times 1 equals 4? 4. So you would write VI or IV?
IV.
IV. and no space between the vanadium and the IV, then space sulfite. Let's try one more. What's Pb? Lead. Leave a space. Find PO3. What's PO3? Phosphite. Awesome. Okay, does lead need a Roman numeral?
Yeah.
Why?
Because lead.
2 or 4. Variable charge, 2 or 4. Now, again, a lot of you may not need to do a plus chart. The lead can either be a 2 or a 4. Can you tell which one it is?
It's a 2.
It's a 2. Awesome. Okay, it's a 2. Let's work it out. Phosphite is a -3. So if you multiply these together, you get a -6. You go outside the parentheses when you multiply. So this side's a +6. Which one of these times 3, don't forget this is right there, times 3 equals 6. 2 times 3, so you would say lead 2 phosphite. Okay? All right, and that's it. And just make sure you start memorizing your polyatomic ions, and that's it for naming ternary